All right. Hello, everyone. This is Ananya Bhargava with you. Um, and we'll be studying computer applications syllabus of classes 9th and 10th for now, and we'll see what we do further. Yeah. So, the first chapter is Introduction to Object Oriented Programming. I'm assuming you all must be really excited to begin with the first chapter. New syllabus, everything new. So am I because even I'm starting something new. And this is the fifth take. So this is making me really nervous. But that's all right. We'll begin with the chapter, right? So we can broadly divide the chapter into two parts. The first being Principles of Object-Oriented Programming Concept, and the second being Introduction to Java. Right. So before diving into the principles, we need to understand what object-oriented programming is, what oriented programming means, right? So first we'll begin with understanding that, and then we'll dive into the principles. Yeah. All right. So the oriented programming is of two types: procedural-oriented programming and object-oriented programming. Right. We will get the content of the slides quickly. Yeah. So, uh, okay, I had put a lot of animation, but I think I should have made it plain. It would have been better, but let's proceed with this for now. So, we'll understand what each one of them is, starting from object-oriented programming. We'll get back to the references, but first let's understand what they mean, right? So, okay, from now on, I'll refer procedural oriented programming as POP. Fine, because it is just too long to repeat procedural oriented programming many a times, right? So, yeah, procedural oriented programming is about writing procedures or methods that perform operations on data, right? See, POP is a programming language that follows a step-by-step approach, which means it breaks down a task into a collection of variables through a sequence of instructions. We can say that each step here is carried out in a systematic manner so that computer can understand what to do, right? Now let's see how procedural oriented programming works through this flowchart that we have right here. Alright, so the main program is divided into two small parts based on functions. We'll see what functions are, but for now, just understand that the main program is divided into two parts based on functions and is treated as separate programs. So your A is divided and B and C are treated as separate programs. Separate smaller programs. A bigger problem is divided into two smaller problems. This is just an example. Please don't treat my words as lakir ki fakir, okay? We'll understand this in a very layman language here, okay? Here we'll consider A as the main program, right? The global data, fine. Now A, in order to get simplified, got broken down into functions B and C. Now, a function, to understand for now, we can say is an organized group of instructions, right? And for further simplification, B and C got divided into D, E, F and G. Now, note here that there can be flow of data among B, C and E, D, F and G. See, what I mean to say is data can flow from C to E. It may or may not flow, right? Data may or may not flow from B to say G, right? So there can or cannot be some flow of data. So there is a main program which got divided based on functions which are now treated as separate programs which further got simplified into um, functions, we can say, or we could say further simplified version of programs to get solved, like a bigger problem got divided further and further into smaller problems till it is very much simplified, and there may or may not be any connection between E, D and E with C and F and G with B, right? Right. Okay, I had just put a lot of animation, which fine. All right. We'll deal with this, right? Now, let's see what object-oriented programming is. So, as the name suggests, it is object-oriented, right? Okay. So before we proceed further, let's take a pause here and understand what classes are, what objects are, and what data types are. We'll understand all of these, um, like the very basic of them, just for you to get an idea, so that you can understand this better, right? All right, we'll begin with data types. Okay, now the term is really self-explanatory, right? The type of data entered is known as data type, right? Now, uh, there are two types of data types, primitive data type and non-primitive data type. So, we'll understand what each one of them are. A primitive data type is predefined by the language, right? Um, and is named by a reserved keyword, right? We'll study about reserved keywords and more about data types as we move further. This is just to give you a brief, just to give you an idea of how things work. An example which we could take of primitive data type is, say, float, double. All of them are primitive data types, which means they are predefined by the programming language. And float and double are reserved keywords as well, right? Now, um, when it comes to non-primitive data type, all right. So if a data type is not already defined by the language, here Java it is, then who shall define it? It is the programming language, and then it is us as the users, the coders, right? See, so either it is defined, either it is predefined, or we need to define it, right? Now, who are we in terms of Java? We can say we are programmers here, right? So we'll have to define it. Hence, it is right to say that non-primitive data type is a data type defined by the user. It is the user defined data type, right? Now you must be wondering, what was the use of knowing all about data types at this point? We'll get to it, right? So, the use of knowing all about data types was because class is a non-primitive data type, right? Which means that it is user defined, while an object is an instance of a class, right? Uh, we'll understand more about them. Okay, we can say that characteristics of objects include state, behavior, identity, responsibility, right? But, um, okay, ma'am didn't understand what is object, what is instance, how are these characters related. Wait, I'll explain further. I'll explain you with the help of this example we see. Where is the pointer? Okay, here it is. Say we have a class named person, and this is an example, so it can be about anything, like literally anything. It can be about animals, cars, trees, anything. Why? Because a class is user defined, and here we are the users, so we can define class based on our choice. At least in examples we can, right? We'll see what there is further for us to define, right? So what we can know about a person. We can know like the very basic things which every person will have, like every human has. Every human has a name. Every person has a name. Every person has an age. Every person has a gender, right? It can be anything, huh? It can be, say, height. It can be weight. But here we have taken the very basic ones, right? Now, here name, age, and gender are objects. Similarly, if we take car as our class, what does every car have? Every car, okay, blooper. Every car has a model number. Every car has a color. It can't be colorless, right? Every car has a price. You can't take it for free until you steal it. Don't steal, please. Uh, okay. Now you can see how an object inherits some properties of a car, of the class. Like a car will always have a model number, a color, and a price. Similarly, a person will always have a name, an age, and a gender. See, now you know why object is an instance of a class, because it always has some properties of the class, right? I think I got just confused a lot between has and have, but please cooperate for now. Okay, right. Uh, all right. So we'll move further. Now. Why did we need to know all the information that we learned about in the past 5 minutes? To understand object oriented programming, right? So, in contrast to procedural oriented programming, object oriented programming is an approach to standardize the programs by creating them um, in a partitioned memory area for both data and functions. So, object oriented programming is about creating objects that contain both data and methods. And unlike POP, object oriented programming does not allow free flow of data from one function to another. Object oriented programming is a programming language that uses classes and objects to create models based on real life environment, real world environment. Each object includes a set of data and related functions, and the data values of an object are applicable only within the functions associated with the object. Basically, it makes it easy to maintain and modify the existing code, right? Now, how does it become easy? It becomes easy as the new objects are created by inheriting characteristics from the existing ones. You are able, you'll be able to relate this with the example I mentioned earlier, um, right? Uh, in simple language, what happens is the program is divided into small chunks called objects, which are instance of classes, right? Now you know what was the use of understanding objects and classes, right? You will be able to understand better when we see the difference between object oriented programming and procedural oriented programming, right? All right, repeating the process. So now that we have understood what data types are, what classes and objects are, we will finally see the difference between POP and object-oriented programming. All right, so POP emphasizes on functions rather than data types, right? Whereas OOP, object-oriented programming, I will refer to as OOP or the OOPS concept, something like that. So don't get weird out if you hear that from me. Right. Whereas object-oriented programming is a modular approach which allows the data to be applied within stimulated program area. So, um, okay, we'll see the different differences and get to know about it in detail. Don't worry. It also provides the reusability feature to develop productive logic, we can say, which means it gives more emphasis on data. मैम कुछ नहीं समझा, वापस सुनो. Object oriented programming is a modular approach which allows the data to be applied within stimulated program area, right? It also provides reusability feature to develop productive logic, which means it gives more emphasis on data, right? Now, function in procedural oriented programming shares global data, right? Functions share global data, fine. So also here we saw earlier in the example that A was the global data, was the main program, so which further got divided into functions based on functions, right? So POP shares global data, hence we can say that it is less secure. But object-oriented programming ensures data security of the program through data hiding. Now, what is data hiding? Data hiding refers to showing of only the essential features while hiding the non-essential ones, right? So you are only able to see the code which is there in front of you. Suppose there's a function in Java which you'll study further, which is math.sqrt, which basically gives you the square root of a number. So you just enter math.sqrt and in parentheses say you want the square root of 4. So you'll get the answer as 2. But you do not know the logic which is behind finding the square root of a number. That is there in the backend, but you do not know it. This is because of data hiding, right? We'll study about this further today only, right? Um, all right, where were we? Just lost the track. Okay. So, in procedural oriented programming, the data values are global to all functions, right? Which may require you to make necessary changes in all functions due to any change in data value. तो इसको क्या हम मान सकते हैं ना, एक कोई फंक्शन होता है which is global, fine, and now while suppose while executing a program you get an error, it is not working properly. तो क्योंकि अब वो वर्क नहीं कर रहा है तो जितनी जगह इट हैज़ बीन यूज्ड उतनी जगह यू विल हैव टू गो एंड मेक द नेसेसरी चेंजेस in the data values, right? Which makes procedural oriented programming unsuitable for solving complex problems if we talk about it practically, right? Now, as we know that object oriented programming does not allow free flow of data from one function to another. Like इसमें क्या हो रहा था, in procedural oriented programming there was flow of data between say BNF and DNC. There can or cannot be flow of data, it was like that, right? But if we consider this as a flow chart of object oriented programming, there will not be any flow of data between PNF and CND, right? So if we are considering it as the flowchart of object-oriented programming, is going to be vice versa. So D, E, F, and G have to be on the top, something like so. It is going to be like this. We will have something like this, right? So there is not going to be any flow of data among them, right? इसके बीच में and इसके बीच में कोई flow of data नहीं होगा, fine, which makes it beneficial for solving complex problems in real situations, right? Now, procedural oriented programming follows top-down programming approach. Now, in top-down programming approach, the focus is on breaking the bigger problem into smaller ones. and then repeat the process with each problem, um, till we get to a very, very simplified version, right? You will be able to understand what I just said with the help of this flowchart, right? Whereas object-oriented programming follows the bottom-up programming approach. In bottom-up programming approach, the focus is on identifying and resolving smallest problems and then integrating them together to solve the bigger problem. So let's understand with the help of this flowchart, right? Um, these are the smaller problems. So they got identified, they got resolved, they further got integrated together into comparatively bigger problems. They got solved and then they further got integrated into a comparatively again bigger problem, right? So this, we are just dividing 1 into 2 and 2 into 4. It does not work like that. It is just for example, just for you to understand for now, right? There is a vast process which happens behind in a couple of seconds, not even that, right? All right, now let's move further. All right. Uh-huh. There is just a lot of animation that I have put. Please bear now. All right. So after all the differences and data types and objects and classes, let's finally study the basic concepts of object-oriented programming concepts. So, the basic concepts of the OOPS concept include inheritance, data abstraction, polymorphism, and encapsulation. We'll see what each one of them is, starting from inheritance, right? All right. So, alright. So we can say that inheritance is an important pillar of object-oriented programming, right? It is the mechanism by which one class is allowed to inherit the features, fields, and methods of another class, right? Now, some important terminologies related to inheritance include base class and derived class, right? So, the class whose features are inherited are known as base class, also known as superclass or a parent class. And the class that inherits the other class is known as a derived class, also known as subclass, extended class, or a child class, right? The subclass or the derived class can add its own fields and methods in addition to the superclass fields and methods. So, okay, um, we'll see with this example right here. Now, in the example of inheritance, class bicycle is the base class, right? Class mountain bike is the derived class that extends bicycle class, right? So, as I told, mountain bike can have its unique features, its unique fields and features, but it will be like it is derived from something, right? It is derived from the base class. So there will be some basic features which mountain bike will have of the bicycle. Mountain bike has same two wheels, right? Bicycles have two wheels. That's the feature of bicycle. So that's what I said, the subclass or the derived class. The derived class can have its own fields and methods in addition to the methods of the base class, right? So these are the classes here. Inheritance again means inheritance again means sharing of some properties of one class with the other class, right? The properties are shared, both of them have two wheels, both of them move when you pedal them, right? So these are the properties which are being shared. We can say, and this is all in very, very layman language, right? All right. Now let's proceed further and see what data abstraction means, right? All right. So this is gonna happen throughout, I guess. Fine. So, data abstraction is the process of hiding certain details and showing only the essential information to the user. Now, this is very, very easy to understand, all right? Say, in real life, we have brakes in a car, right? We know that its work is to stop the car, but we do not know the mechanism of levers working inside of the car to stop it, right? Similarly, in Java, we have certain functions whose work we are aware of, but the coding behind it is hidden. Like I gave you the example of math.sqrt, right? Um, it's like its use is to give the square root of the given input. Now here again, see, we know its function, but the background coding that is performed by the computer is not known. Computer doesn't know on itself how to take out the square root, right? See, computer only does what you tell it to. तो उसको पहले किसी ने बताया होगा कि स्क्वायर रूट कैसे निकालते हैं, and that's what it follows, right? This function must have been written by someone, right? There must be code कुछ तो पीछे. So that is how it works. Act of representing the essential features without knowing the background details, right? You may confuse it with data hiding too, but please don't. We'll see it further. Right, so polymorphism is the ability to, okay, give me a second please, let me get all of this together first. Right, so polymorphism is the ability to process objects differently based on their classes and data types, right? It is the process of using a function for more than one purpose. Okay, we know that to get the volume of cuboid, we'll need its length, breadth and height. Whereas to get the volume of a cube, we will only need its side, the length of its side. But the use of both of them is same. Like we are getting its volume only, right? But the input we are taking here is different. The number of inputs taken in case of cuboid are 3 and the number of input we take in case of cube is 1. Getting the gist of it, how one function is used for more than one purpose. Like it is used for getting volume only, but how differently it is working, right? How the function volume is acting differently based on class and data types. Getting? Alright. Okay. So you must be used to it right by now, right? बार बार वही. Fine. No worries. I'll ध्यान रखो from the next chapter that I don't put animations in there because it just becomes a lot confusing for me too. Now, encapsulation in Java is a procedure of combining data members and data methods of the class inside the user-defined class. राइट, डेटा मेंबर्स एंड डेटा मेथड्स जो हैं एक क्लास के, उसको उस क्लास के अंदर जो एक यूजर डिफाइंड क्लास है उसी में रखना है, बाकी वर्ल्ड को हमें नहीं दिखाना है कि उसके अंदर क्या है. फाइन. एंड इट इज फॉर दिस टू हैपन, बाकी वर्ल्ड को हमें नहीं दिखाना है उसके अंदर क्या है. So when we learn the basic structure of a Java program, we'll get to know that the class can be defined as either public or private. Fine. So in this case, we'll have to declare the class as private because we do not want the world to see the implementation behind the codes we have, right? So it is the mechanism that binds together code and the data it manipulates. In other words, we can say that encapsulation is that protective shield that prevents the data from being accessed by the code outside this shield, right? So you eat capsules when you are 12. So there are small balls inside the capsule, right? But there is a protective covering. So the declaration of the class as private is that protective covering which does not allow the outside world to come in contact with it, right? The data in a class is hidden from other classes using the data hiding concept. Remember, we had a word about this earlier. And data hiding is achieved by making the members or methods of the class as private, right? And the class is exposed to the end user or the world without providing any details behind implementation using the abstraction concept, right? So we can say that this is a combination of data hiding and abstraction. You see how capsule works, right? It is mixed. It is like a mixture of several medicines, we can say. It may or may not have, but the outside world, it will not get mixed with any other medicine. Like it is a capsule, अंदर है सब, बाहर की world से उसका contact नहीं होगा, because there is a protective shield, right? There is a plastic or whatever silicon coating there is, right? Similarly, अगर हम class को private declare कर दे रहे हैं, तो the outside world will not be able to see the code behind, the code we have used, the code we have implemented, right? All right, and with this, we have come to an end to the first part of the chapter. Yay! Right? And now we'll begin the second part, which is Introduction to Java, right? So, yeah. We'll be getting a very basic introduction to Java. Like there is introduction to Java, but this is like the really basic thing, like really basic, right? So we'll begin with it quickly, right? All right. So before starting with anything, before starting something new, we must always know a bit about its history, how it originated, who made it, why, how, and why is it named Java? I know something else. Okay, I personally hated history, so I know how boring it is to study about history. But imagine you talking to your relatives about Java, about your computer syllabus, and they ask who developed Java, and you're blank. That wouldn't be something nice, right? So it's a bit theoretical. Feel no, it's always interesting to understand the background of something, how it originated, how its name came, right? So at least this was. So the programming language was developed by James Gosling, who initially named it Oak. Uh, Personal opinions, I feel Java is better than Oak. Oh, no offense to anyone. Alright. It was named Oak after an oak tree that stood right outside Gosling's office. And very creative. No offense, please. Alright. Later, the project went on by the name Green and was uh, finally renamed Java from Java coffee. This is a type of coffee that originates from Indonesia, right? So it was like James, while having a cup of coffee nearby his office, noticed that Java is just a name and not an acronym, and hence decided to name it Java. And that's how we got our name Java. Nice name. Alright, let's move further. So, yeah, again, uh, give me a minute, please. Alright. So yeah, this is the chronology of how languages were known. So it all began with zeros and ones, the binary language. We all know that, right? uh, the binary code. And this is what computer still understands, the binary language. We'll understand, right? So anything you write into the computer, you are writing something. Suppose you are writing Java, it is a programming language. You can understand that programming language, but computer will not understand it. It is just like, it will be just useless for it. उसको नहीं समझेगा कुछ भी. It only understands binary language. So in that case, the programming language first gets converted into assembly language, which further gets converted into binary language, which the computer understands, right? All right. Then got introduced the assembly language. Okay, so assembly language is the one which is only entitled to work on the PC in which it was created, right? So if I'm using something on my PC and if I want to use it on your PC, it won't work because it only works on the PC in which it was created, right? Then came the programming language, which we can divide into low level language and high level language, LLL and HLL, right? The low level language is interpreter based and the high level language is compiler based, and that is what we are going to see next. What is interpreter and what is compiler, right? All right. You all need to bear with this, right? Why is this not working? What happened? What is the issue? Okay, got it. I will quickly get through it. Also, if there's any background noise, please ignore it because it is raining really heavily right now here, right? Alright. So, firstly, when you write a program, see what we write is the source code, right? As I told you, which we as humans can understand. But the computer only understands machine code, the binary language, zeros and ones, right? So the source code which we write will first be converted into byte code, which we can refer to as the assembly language, and then into the machine code. We'll see this in detail in the next slide. For now, say, okay, for the program to be converted from the source code which we write to the machine code, two processes can be used, interpreter and compiler. Not exactly processes, but interpreter and compiler converts machine code, converts source code into machine code, right? And we'll see what is the difference between them, right? All right. So interpreter would convert the source code into machine code line by line. All right. So we'll suppose this is our program, right? Okay, this is our program here. Now, the first line gets interpreted, then the second line gets interpreted, then the third, and so on, like line by line. But the moment it finds an error, it shall stop there and wait for you to remove that error and then convert further. What I mean to say is, say we are using interpreter. The first line got interpreted nicely. The second line was getting interpreted, but there got an error here. Now the interpreter will wait for you to resolve this error, to debug this, and then only it is going to move further and interpret further. It will wait here until you remove that error. It will not move further. And suppose you find an error again at the end of third line. So ये हो गया रिजॉल्व, आगे किया इंटरप्रेट किया, सेकेंड लाइन किया, थर्ड लाइन के बाद वापस एरर आया, तो ये यहीं पे रुक जाएगा. इट विल वेट फॉर यू टू अगेन रिजॉल्व दिस एरर एंड देन आगे बढ़ेगा. एंड दैट इज हाउ इट वर्क्स. जहां एरर मिला वहीं रुक गया. जब तक तुम उसको रिजॉल्व नहीं करोगे वो आगे नहीं बढ़ेगा. एंड द मोमेंट यू रिजॉल्व इट, इट इज गोइंग टू मूव फर्दर, राइट? All right. So this explains how the errors are reported as encountered, right? जब error मिला वहीं पे report किया, and it won't move further until you remove that error, until you debug it. This explains you the second point as well. This one, right? Whereas we will again assume this to be the code and talk about in case what happens in case of compiler. The compiler shall convert all the code at once, right? It was doing it line by line. It shall convert all the code at once and report all the errors to you at once. Suppose we have an error here and here, right? So what it is going to do is पूरा program compile कर लेगा. It shall not stop here or here to tell you that there is an error, please debug it, and then I will move further. No, it shall compile all the program at once. It shall convert all the program at once. Then it is going to report you that there was an error in line 2 and there was an error in line 4. Please remove the error and then I shall move further. Right? Like further as in we'll see what happens after your program gets compiled and how it gets done into machine code. We'll see this in the next slide. For now, understand this, that this gets converted line by line, whereas compiler converts the programs at once, the whole code first, and then it shall report you all the errors at once. Right? This very much explains the second point as well. Now, think of it, which one is easier? Which one would be easier? The one which converts line by line. There's an error, it stops, it waits for you to resolve, then moves further, then stops, then moves further, or something that converts all at once and then reports you the errors so that you can remove it. Which one is easier? See, practically speaking, compiler is much faster and much easier to use if you are solving complex problems, right? Complex real life problems in Java. Fine. Like interpreter would be very much slower. It will wait for you to resolve all the problems and then move further, and then wait for you to resolve the problem and then move. Whereas compiler would do it all at once. But at the same time, we can say that interpreter is more accurate, right? But it is not possible for you to sit there all the while. जब जब problems आ रही हैं तब तक उसको हम हटा रहे हैं, right? It will be a lot tedious when it comes to huge programs, huge programming codes, right? Thus, interpreter is slower, though it is accurate, but it is slower and tedious for talking about practical conditions. Whereas compiler is much faster as compared, right? You can understand, like understanding what I mean to say, right? How compiler will be slower, how interpreter will be slower, how interpreter is more accurate but slow, right? All right. So COBOL, BASIC, Pascaline are some of the programming languages that use interpreter, whereas C, C++, Python are the programming languages that use compiler to convert source code into machine code, right? And now we'll move further to understand what is the flow of program. How does source code gets converted into machine code in Java, right? All right, so this is the flow chart of how Java works, right? Just a minute. Okay, I guess it is fine. All right, so Java uses both compiler as well as interpreter. Right, so the source code is first compiled into bytecode, which we can also call as intermediate code, and then comes JVM, whose full form is Java Virtual Machine, which acts as interpreter for the language. So there is an interpreter for Windows, for Linux, and for Mac, and it works depending upon the kind of system you are using. So the byte code through JVM gets converted into machine code, and machine code is also known as object code. So anywhere you find different terminologies for the data, you must not be blank, and you must know कि किसकी बात हो रही है, right? Now you must be thinking that interpreter was hard to use, तो उसको यहाँ पे use क्यों कर रहे हैं? See here, the source code is already getting compiled first. So alright, so if you have ever written a Java program, you must know that you need to compile the program in order for it to run, right? So the moment you compile it, it got compiled, right? All the errors got removed by you. Compile successfully तभी होगा when all the errors will be removed by you, right? So when you remove all the errors, and when it comes to interpreter, there is no error to be removed. And when there is no error to be removed, it will smoothly get interpreted and go from bytecode to the machine code. Understanding, right? Alright. Now, you see these little ones here? We could say that .java files through a Java command gets converted into .class files, which again through a Java command gets converted into .execute files. See, now you know how you write a source code, but the computer understands it as machine code, right? Alright, moving forward. Alright, see, here are some of the unique features of Java. They are not here yet, on the way. Alright, the first one is JVM, the one we came across in the previous slide. JVM, as I told you, stands for Java Virtual Machine, which is the interpreter for the language. Now, a Java Virtual Machine is a virtual machine that enables a computer to run Java programs as well as programs written in other languages that are also compiled to Java bytecode. Now, there are other languages as well whose codes are compiled into Java bytecode, right? So JVM works there too. So simply we could say that JVM converts Java bytecode into machine code. It interprets it, right? Now you must be thinking, okay, interpreter was used to encounter errors in the middle of the program. Alright. So in the previous slide, we saw that, right? I told you how, we will roughly draw the diagram here again. This was your source code, which got converted into bytecode. Then here came JVM, right? And then was your machine code. Now, if the source code is first compiled into bytecode, the compilation process is done. The code which will move from here to here will be error free, will already be debugged. There will be no need for it to be debugged at the time of interpretation, right? When JVM will be in use, the code there will be no use for code, like there won't be any errors which the program shall encounter and stop in the middle, right? So this process won't be slow. It happens in blink of eyes, like बहुत जल्दी होता है, right? You see how quickly you can see the output of a program. You write the code, you compile it, you go, you run the program, and there is its output, right? That's how quick it happens. Alright, we'll remove all of this from here. Yes. Yeah. Now, let's see the next one, which is robustness. So, robustness is the capacity of a computer system to handle the errors during execution and manage the incorrect input of data. Right? So, we can say that suppose you asked for a number from the user. You are a coder and you asked a number as an input from the user. But the user gave you, say, a name. My name is Ananya. I will take it as an example. The user typed there Ananya. Now, Ananya is not an integer, right? It is a string because it is a combination of words. It is a combination of alphabets. It is a string. You asked for an integer. The data type you assigned to the variable was int, but you got an input of string. Now here the robust feature of Java shall be used, and um, it will know how to handle the errors during execution. It will manage the incorrect input of data. It will show you a message that this was not the preferred input. Please give another input. You'll have to run the program over again and give the right input, right? See, we can see that Java is robust because it utilizes strong memory management. It is capable of handling runtime errors, the one I told you, explained you right now, supports automatic garbage collection and handling, exception handling. There are exceptions everywhere, and avoids explicit pointers, right? Now, means it can be run, it can be, so Java is something which can be made and run on any operating system, right? You can write it anywhere and it can be run anywhere, right? It is not specifically made for the system in which the code is written, as we had it in the assembly language. Assembly language will only work, it was only entitled to work on the system in which it was originally written, right? It is just the vice versa of the robust feature, right? Now, what is JDK? We will see what is JDK, what is Java Development Kit in the next slide, right? All right, I will get all the data first. Also, please, I just highlighted it and I forgot to remove the highlight portion. Just please ignore that part, right? And please give me a minute. I need to have a sip of water. All right. So JDK stands for Java Development Kit. Now, Java Development Kit is needed for developing Java applications. Right. Now, what are Java applications? Java applications are Java programs developed by the users or the coders, which means that they are developed by us, right? We are the users here, we are the coders here. It means that they are developed by us. So basically, JDK consists of packages, and a package has functions, right? JDK consists of packages, and a package has functions. Okay, let's take an example into account. So Java has many libraries. Now you must be thinking what a library is. So library is set of packages, right? Now, considering the library java.math for now, It is used for various mathematical calculations, be it a square root, be it a cube root, power, and whatnot. So java.math for now say has functions sqrt, right? For the whole of the chapter, for the whole of the lecture, we have been taking math.sqrt as an example, so we'll consider it again, right? So the function the function sqrt, which is used to get the square root of a number. Now it has the syntax math.sqrt and the variable, right? Like math.sqrt and the variable. Now here, why is it math.sqrt? Why is it not english.sqrt? Why not hindi.sqrt? Why is it math.sqrt? It is because it is listed under the library java.math, right? Thus, all the mathematical functions under the library java.math will begin from math. Say math.sqrt, math.cbrt, math.pow, right? This is like the very basic introduction to it, right? We learn the proper syntax and how to use it in our programs as we study further, right? This was because why do we use it? Why do we write math.sqrt? Why not something else, right? Now, there are some default packages too that are already present in Java, which we like. Okay, right. So there are some default packages that are already present in Java, which include java.lang, java.io, right? So all the functions under these libraries can be used without adding the library to your program. Now suppose for java.math, you can use a number of functions, but not all. This is just an example. Please don't consider it like if I'm talking about java.math, it is because you people know a bit about java.math already from your previous classes. That is why I'm taking java.math into consideration and not any other library, right? All right. So you can use a number of functions, but not all. And in order to be able to use all the functions, you will have to write the command import.java.math.asterisk with a semicolon. So the basic syntax being import dot the library name, which is java.math asterisk and a semicolon, right? Now here import is used as a call command. The library name is written to be specific. Which library do we need to call, and the asterisk symbolizes that you have called all the functions stored in the library, and in the library, like here we are talking about java.math, all the functions that are stored in java.math are being called, and any one of them can be used by you, right? And whenever the function you need to use, you can call the function and now it can be used because you have called all of it. Again, as I told you, this was just an example to give you a brief and a fun fact. You don't really need to import the math library as it is already under java.lang, and nothing under that package needs to be separately imported, right? uh, I already told you this was just for an example. Please don't consider it. Consider the things that are being talked, but not this example, please. Now let me get the data. And I told you that we'll discuss about Java keywords, Java reserved words. Now, here it is. And Java reserved words are simply keywords that are predefined and have a unique meaning and functionality in Java programming language. So these keywords are known as Java keywords, which mean that they cannot be used as a variable name, as a class name, a method, or any other identifier, because they carry some unique and specific meaning to the compiler, to the language. Thus, it cannot be used as any one of them, because then it will be um, confusing for the language to understand if it was allowed to use it. Thus, it is not allowed to use it, right? There are a total of 57 reserved words in Java. And meanwhile, in this huge list of Java keywords, there are some which are not used anymore. Some of the examples of the Java keywords include public, static, while, char, switch, default, package, and so on. There are a lot. Moving further, we will broadly study something about Java programs, and yeah, alright. So broadly, Java programs can be divided into two types. Java applications, also known as standalone system, and Java applets, also known as internet applets, right? Now, applications are just like a Java program that can be executed independently without using a web browser, whereas applets are small Java programs that are designed to be included with the HTML web document. They require a Java enabled web browser for execution, which means when you use a Java technology um, enabled browser, when you use a Java technology enabled browser to view a page that contains an applet, that applet code is transferred to your system and is then executed by the by the Java virtual machine, by the browser's JVM, right? So now you know how JVM was referred to for converting Java bytecode into the machine code, right? Now, the application program requires a main method. Um, so, if any one of you have written the basic structure of a Java program, you write public static void main. So, this requires that main method for its execution, but the applet does not require the main method for its execution. Instead, init method is required, which we do not need to know because we are studying computer applications, Java applications, like we are going to create program ourselves. Um Also, easily we could say that Java applications are user-defined codes, user-made codes, whereas applets are codes which are downloaded via internet, which are then interpreted by browsers JVM, right? Now, further, the Java C command, which we saw in how Java works slide, you could go back, rewind, and see there. The Java C command, java.c or Java C command, is used to compile applications program, which are then executed using the Java command, whereas the applet programs are compiled with Java C command and run using either applet viewer command or the web browser, right? Because they are internet codes downloaded via internet, right? Java application programs have full access to local file system. Because you are making it on your system, it will have full access to the local file system. But applets don't have the access to local network or the local disks because they are being downloaded, right? The moment you encounter them, your system shall download it, your browser shall convert it, and that's how it works. Now, applications can access all kinds of resources available on the system, right? But applets can only access browser specific services because they are on the browser again. right? They do not have access to the local system. Very well clear, right? Further, we can say the installation of a Java application on local computer is required, right? Uh, you need to install Java, right? Applications can execute the programs from the local system. We very well know that an application program is needed to perform some tasks directly for the user. It cannot run on its own. You need to run it. The void main thingy when you run the program. We'll see that further too. It needs JRE to execute. Connectivity with other servers is possible, right? It supports reading and writing of files on the local computer. Applications can access systems data and resources without any security limitations. Java applications, we can say, are self-contained and require no additional security because they are trusted, because they are on your computer, they're on your PC. Whereas Java applet does not need to be installed forehead, right? Applets cannot execute programs from local machine. See, they won't execute because they are on the browser. They won't execute the local disk data because they are on the browser. You do not need to install it forehead because you encounter it somewhere, right? Now, an applet program is needed to perform small tasks or part of them. It cannot start on its own, but it can be executed using a Java enabled web browser, right? It will not be able to connect to other servers, again browser found. It does not support the reading and writing of files on the local computer. We have discussed this a lot of times in the past 5 minutes, I suppose. Applets are executed in a restrictive environment with tighter security because it is browser found, right? They can only use services that are exclusive to their browsers, and applet programs cannot run on their own. Um, but for applets to run, you need the maximum level of security, right? That is the necessity, right? Yeah, that was it about applications, Java applications and Java applets. You must know that Java application is also known as standalone system and Java applets are also known as internet applets. If you are being asked to write the difference between them, all the information that I told you, you can or cannot write on your paper. It was really useful for you to know that. It will be really useful in the future. In very layman language, we can say that Java applications are user-defined, user-written programs, while Java applets are codes downloaded via internet which can be interpreted using JVM. Right? Alright, let's move further. Alright, so you must be wondering that all the data we learned till now is okay, but how do we write a program in Java? That is what we are studying Java for. What is its basic format? Uh, so, we'll be seeing what is the basic format of Java, starting from comments. Okay, let me bring all of it again. Right, alright. We can write comments at the starting or the middle or in the middle of a Java program, right? Comment statement is a non-executable statement. So basically comments are readable remarks which can be written anywhere in the program for the sake of the users to understand that what action is going to be taken in the program or in the statement, right? Now, we can see here that comments are of three types: single line comments, multiple line comments, and documentation commenting, right? So single line comments start with two forward slashes. Alright, so the slash like this is known as a forward slash. whereas a slash like this is known as a backward slash, right? So forward slashes, two forward slashes is used for single line commenting. So any text you write after putting two forward slashes and the end of the line is ignored by Java, which means it will not be executed, right? Now, the second being multiple line comments, which start with one forward slash followed by an asterisk. This is known as an asterisk, and which ends with a asterisk followed by a forward slash. Any text written between this is going to be ignored by Java. Similarly, in documentation commenting, it starts with a forward slash followed by two asterisks, ends with an asterisk followed by a forward slash, and any text written between here is going to be ignored by Java, right? There is also something known as inline comments, which can be written with Java statement using again simply two forward slashes. Again, this is forward slash and this is backward slash. You will use both of them at some instances. This is used for comments. This will be used for other purposes about which we will learn in the further chapters. All right. Okay, let's move further. A Java program. This was some animation that I had put. All right. So this is the basic structure of a Java program, and in this program I'm simply printing a quote. So here the first line is a comment, a single line comment. So this is just for the understanding or like an overview of what the code is about, and Java shall not execute this line, right? The second line having the declaration of class. Now here example is the name of the class. Now you must note that the name of the class should not be a reserved keyword, a Java reserved keyword, because reserved keywords carry special and different meanings to the compiler, right? It should be meaningful and relevant to the programs. This was an example of the basic structure of Java programs, so I named it as example. All right. Then the word class is a keyword, and the word public is an access specifier. Now you must be wondering what an access specifier is. So access specifiers are entities that help us to restrict the scope or visibility of a package or a class, right? This is a class here whose visibility we can set as public or private, right? When do we set it as private? When we do not want whole of the world to see our code, right? The one we learned in polymorphism, we set it there as private, which was a combination of data hiding and abstraction, right? Now, then we have the opening, an opening parenthesis, which indicates the opening of the class. Then in the next line, we are declaring the main function. Now remember, we had to declare the main function in Java applications in the user defined codes, right? This is the declaration of the main statement. The execution of the program shall start from this line. So again, public is an access specifier, static is a reserved keyword, void is the return type, right? Void basically means nothing, right? Like this is getting printed, but you're not returning anything, right? So void is the return type. We'll study about all of this in detail as we move further, right? And main is the function, and the opening and closing braces you see here are arguments, right? Then we again have an opening parenthesis. This indicates the opening of the main function, right? Then we have the print statement, which we can refer to as the output statement, which ends with a semicolon, which we can also call terminator. the termination of each statement is indicated with a semicolon, right? So if we are performing your addition or subtraction or any operation like that, like c is equals to a plus b, and we have assigned a plus like a and b some values, or we are taking values of a and b from the user, right? They must end with a semicolon. They must, like, the sentence, the statement has to terminate, and it terminates with a semicolon. Then we have a closing parenthesis. This bracket here indicates the closing of main function, because main function started late. So this indicates the closing of the main function, followed by the parenthesis, closing parenthesis, which indicates the closing of the class example, right? So it is just like that. The function which the break. Okay, consider it as an example. Suppose you go school by bus, right? So there are 4 stops, right? Okay, we'll draw it here. There are 4 stops: 1, 2, 3, and 4. This is your bus. It shall go that way, right? So the person who lives at nearby this stop, who goes by this stop, will enter the bus first, then 3, 2, and 1. But while returning, the person who gets out of the bus at the first stop will get out of the bus first. Similarly, it's the case with the braces, right? Alright, let's move further. Now we had the 2 printing statements. Now, like, we have 2 printing statements. The one which we used in the previous slide was system.out.println, but we have something also known as system.out.print, and we are going to see the difference between both of these printing statements in the next slide. Alright, let's move further. Alright, so this is an SOPLN statement, system.out.println statement, which I am going to refer to as SOPLN, and the other one is SOP, right? Now, by now you must already know the basic structure of the program: public being access specifier, class being the reserved keyword, an example being the name of the class, starting of the class, public again being access specifier, static being a reserved keyword, void being the return type, main being the function, the arguments followed, opening parenthesis which indicates the opening of the main function. The execution of the program starts from here, right? Then we have 2 statements: system.out.println1 and SOPLN2, which are ended with the terminator. Now, ignore this portion for now, and we'll see how how the program is approached while it gets printed, right? So consider this as your output screen. Fine. The program saw, like, it was getting compiled. It came here, it saw a print statement. Now it knows that it has to print something, right? System.out.print. Fine. Now, to print what? Print 1. The cursor of the program was here. Just a second. Okay. The cursor of the program was here, right? So it is going to print something. It is what is it going to print? It is going to print 1. Printed 1. Now, because we have an ln here, the cursor from here would move to the next line. It moves here, right? Now, the next line we have system.out.println. Remember the cursor we have on the second line, println. We will see system.out.print. Print what? Print 2. Thus, the computer is going to print 2, and we have the cursor right here. Okay, this is not 1, this is your cursor. We have the cursor here. Then because we have an ln here, the cursor will be on the third line. So suppose you print something again, you print 3, it is going to get printed here, and if it has an ln, the cursor is going to move to the next line, right? Alright, and that is the output we are going to get, and that is the exact output we got on compiling and running the code, right? Let's see what system.out.print is. So system.out.println was bringing your cursor to the next line, but system.out.print would let the cursor be on the same line, right? So again, ignore this for now, the output screen which is already there, and consider the thing I'm drawing as the output screen. Now, all of this is compiled. We know what the basic structure of program is again. The program sees the print line. Now it knows that it has to print something. System.out.print, the cursor is over here on the first line, on the very first line. It is going to print what? It is going to print 1. Now the cursor is right here, right? It has not gone to the next line because there is no ln over here, right? So the next thing, it is going to come here on the second line, system.out.print, print what? Print 2. Now there was no ln in the previous line, the cursor still remains here, thus it is going to print 2 in the same line and not the next line, right? So 2 gets printed here and the cursor is here, and because it has again no ln, the cursor shall remain here. And suppose you are going to print system.out.print ln3 in the next line. Suppose you print it, the 3 you print is going to be printed here, and because an ln is encountered, the cursor will move to the next line, right? But for the code we have written now, this is the output you will get, and this is the exact output which we got, right? Now let us move further, and there is an example for you to solve in the next slide. Yeah, this is an example for you to solve. Give it a shot, give it a try, tell me what its output will be, how things are gonna get printed. I'll give you a minute and then we'll see how things work, right? Alright. If you need more time, that's alright. Please pause, solve, resume, and then we'll and then see the solution, right? Alright, so this is the combination of SOP, LN and SOPs. So you'll be more clear of how things work, right? Here we are clear about the basic structure again. If not, please rewind, hear it out again, right? Now we see a print statement, system.out.print ln. Ignore this ln part and see it after printing the line, like see if it is there or not after you have printed what it is there inside the double quotes, right? So system.out.println, cursor is on the first line. What is being asked to print? 1 is being asked to print. 1 will get printed here, the cursor being here, but because of an ln, the cursor will move to the next line. Now the cursor is here, right? The cursor is here, right? Now there we got the second line. Just a minute. Okay, no issues, right? We come to the second line. we see system.out.print, print what? Print 2. Because the cursor is on the next line, it is going to print 2 here. This is no space, this was just the cursor here, and after printing 2, the cursor will be after 2. The cursor will be here and not here. Alright. Just fix this. Yeah. So the cursor will now be here, and because there is no ln, it will stay here and it will not move to the next line, right? It will stay here. Then we come to the third line. We see system.out.print, print what? Print 3. We will print 3 in the same line because there was no ln in the previous line, right? So 3 got printed here. Where is the cursor right now? The cursor is here. Now, but because there is an ln in this line, because there is an ln in the third statement, the cursor from here will move to the next line, right? The cursor from here will move to the next line. Then we come to the fourth printing statement, which is system.out.print 4. Print what? Print 4. 4 is gonna get printed here, and your cursor shall be here, right? Now, because there is no ln, the cursor will not move to the next line, and suppose the next line was system.out.print 5. It would have been printed here and not in the next line, right? Now we'll see what the output we got from the computer, right? Was this the output? We'll ignore this circle, obviously. Did we get 1, 2 and 3 in the next line and 4 in the next line, or something else, right? Right. So the output we assumed was right. And what we did right now, the other output window we created, we will call it as dry running the program, right? So we will assume its output. We will try and find out the output with the help of discussion verbally, or with the help of paper and pen, not using actual Java, right? On the principles of it, but not actually running it on computers, right? This is called the dry run process. That's what I call it. Alright, understood all of this, but how do we make a program? Where do we write it? Getting to it, how do you open Java? How do you make a project? कैसे program बनाते हैं? Coming to it, right? Alright, so in this slide we'll see how do we start, compile and run a program, right? Okay, so here is the screen recording getting played, which I had already recorded. So either you will have a desktop shortcut, or you can open it through the start tab. You just have to write BlueJ. If it has already been pre-installed, right? Or else you need to install it, and then now you will see a blank screen when you open it. This is my series of programs which I have created. In that case, go here, go to new project, give your project a name. I have given it Ananya 2022. Then create a project, go to new class, give your class a relevant name. It must not be a keyword, it should be relevant to what you are making. Throughout the program I have used example as a word, so parampara jari rehni chahiye. We'll open the program, double click on it to open, and then we will go Control A and backspace all of this. Then we can start writing our program, right? Now I'll quickly I have quickly written a code in here. So public, which is an access specifier, it could be private as well. Class is a keyword, reserved keyword. Now if you write, like I had given this program a name example. Now here and here the names will change from example to something else if I write something else. Like I wrote code, the names got changed, but it should be relevant, right? Now, this is the beginning of class, and I guess this is some update in this feature of Java which brings the curly closing braces when as and when you enter the opening curly braces. In case you don't have it in your Java, you have to put the closing braces as well, and while writing programs on paper pen as well. Then again, public static void main, public being X specifier, static being the reserved keyword, void being the data type, and main being the function. And then the arguments, again, closing braces, opening were just getting automatically printed there, automatically प्रकट हो रहे थे, printed नहीं. We will write the print statement. Right? Why am I not writing the print statement? Right. Finally, system.out, out, system.out. All right, it came system.out.println, or it could be print, right? Braces, double quotes, whatever you have to print. I wrote here hey, double quotes close, and a terminator, and then you will compile a program. If you see an error, you will have to debug it. If not, it will be successfully compiled. You will cross it, you will come here, you will right click, you will go to void main, you will click on it, and you will see its output. Now sometimes what happens is like I would suggest you to clear whatever the output you have got. Now why I suggest this, I will show you. Give me a minute. Like I have cleared it for now. So the next time I run the program, I will see a plain hey again on the clear screen. But if I don't clear it, I will see two hays because the previous output was not cleared earlier, right? So I suggested to clear it because this was just a hey program, but in long lengthy programs, it will just become too complicated if you see two completely different outcomes of different programs, right? Then we can easily close it. And yeah, that was it. That was done, right? So yeah, that was it for the chapter Introduction to Object Oriented Programming. We are done with it. We completed it in what, 1 hour 30 minutes something, right? Do let me know if I was going too fast or too slow. If the speed was fine. If you guys have any problems, I would be more than happy to clear all of them. Leave them down in the comment section, and any other information about me or how you can contact me or something like that, I may or may not leave it in the description box. I am not sure about it right now, but I'll think about it. Alright, so this was Ananya Bhargava, and I'll be seeing you in the next chapter, which is classes and objects. Yeah, so we'll study that together again very soon. Till then, keep computing, keep programming, keep printing random things. Semicolon is must. Okay, chalo, see you in the next one. Bye bye.